Good morning students. This is lecture 4th of class 11th maths chapter 4th. Homework solutions of lecture 3rd. So first is question number 19, that n, we have to prove n into n plus 1 into n plus 5 is a multiple of 3. So first step is let the statement be as Pn. Now for n equal to 1, put in place of n, put 1. So 1 into 2 into 6, which is 12, because 6 into 2 is 12, is a multiple of 3. Therefore, P1 is true. Now we will assume that Pk is also true for some k belongs to natural number. We assumed Pk is true, so in place of n just put k. So Pk will be k into k plus 1 into k plus 5 is a multiple of 3. As it is a multiple of 3, therefore this term is equal to 3m, where m belongs to some natural number. Now we will multiply these three terms and we'll get the result as k cube plus 6k square plus 5k equal to 3m. Right? In multiplication, indication a question of multiples or divisible, I've already told you that find out the value of one term. So we'll find the value of k cube. K cube will now be equal to 3m minus 6k square minus 5k, and let this be as 1. Right? Now we will prove for pk plus 1. So in place of k just put k plus 1. So now pk plus 1 will be k plus 1 into k plus 2 into k plus 6 is a multiple of 3. This we wanted to prove. So we will take this k plus 1 into k plus 2 into k plus 6. Multiply first two terms, you will get k square plus 3k plus 2 into k plus 6. Now multiply these two terms, you will get k cube plus 6k square plus 3k square plus 18k plus 2k plus 12. Solving this, it will be k cube plus 9k square plus 20k plus 12. Now using 1, value of k cube is 3m minus 6k square minus 5k. So using 1, in place of k cube, write the value 3m minus 6k square minus 5k plus the left terms. Right? Now 3m plus this will be minus 6k square plus 9k square. So it will be 3k square plus, solving these two, you will get 15k plus 12. From all the terms we can take out 3 common, right? We wanted to show it as a multiple of 3. Now we can see it is clearly a multiple of 3. So you will write the result pk plus 1 is true whenever pk is true. Hence by PMI, Pn is true for all n belongs to natural number. Clear? Next question number 20th, we have to show that 10 raised to the power 2n minus 1 plus 1 is divisible by 11. So first step, you will write the statement be as Pn. Now for n equal to 1, in place of n put 1. So it will be 10 square minus 1, which is 10 raised to the power 1 plus 1, which is equal to 11. So we have to show that this is divisible by 11. It is obvious, therefore P1 is true. Now we will assume that pk is true. You will write all the statements, which I am not writing. So we have assumed pk is true, so 10 raised to the power 2k minus 1 plus 1 is divisible by 11. As it is divisible by 11, it is a multiple of 11. So this term is equal to 11m. Now find the value of any term. So we are finding the value of this, which is equal to now 11m minus 1. As we will gonna use this result, let this be as 1. Now we will show that pk plus 1 is also true. So first of all, write pk plus 1. In place of k just put k plus 1. So pk plus 1 will be 10 raised to the power 2 k plus 1 minus 1 plus 1 is divisible by 11. This we wanted to prove. Taking this term 10 raised to the power, multiplying 2 with both the terms, 10 raised to the power 2k plus 2 minus 1 plus 1. Now as you know, we know the value of 10 raised to the power 2k minus 1. So writing it as 10 raised to the power 2k minus 1 into 10 square plus 1. Now using 1, we know the value of this. Write it down. 11m minus 1 into 100 plus 1. Multiply 100 with both the terms. 100 into 11m minus 100 plus 1. This will be now minus 99. As we can take 11 common from both these terms, the left will be 100m minus 9, which is clearly divisible by 11. This is what we wanted to show, right? That it is pk plus 1 is divisible by 11. So you will write pk plus 1 is true whenever pk is true. All the statements. Now next question is question number 22nd, in which we have assumed pk that 3 raised to the power 2k plus 2 minus 8k minus 9 is divisible by 8. So if this term is divisible by 8, it means that this term is equal to 8m, where m belongs to some natural number, right? Now what we have done is this term is equal to 8m, but I have taken these two terms as this side, right? And now let this be as 1. We have to prove for k plus 1. So k plus 1 will be, pk plus 1 will be 3 raised to the power 2 k plus 1 plus 2 minus 8 in place of k, write k plus 1 minus 9, which is equal to 3 raised to the power 2k plus 2 plus 2 minus 8k, and this will be minus 8 minus 9, which is minus 17. So we have to show that this is divisible by 8. So we will take this term and writing this first term as 3 raised to the power 2k plus 2 into 3 square. Why I am writing like this? Because we know the value of 3 raised to the power 2k plus 2. So we will be writing like this. Next term as it is minus 8k minus 17. Now using 1, write the value of 3 raised to the power 2k plus 2, which is 8m plus 8k plus 9 into 3 square 9 minus 8k minus 17. Now multiply 9 with all the 3 terms. 9 into 8m plus 9 into 8k plus 9 9s are 81. Minus 8k minus 17. Writing this term as it is, we can see this. If we take 8k common from both of these terms, then it will be 9 minus 1. So this will be 8k into 8 plus 81 minus 17 is 64. We have to show that this is divisible by 8. So we have to see if 8 is common or not from all the terms. So as we can see clearly that 8 is common from all these 3 terms. So it is divisible by 8, right? Clear this question? Now question 23rd, in which we have assumed that pk is true, that is 41 raised to the power k minus 14 raised to the power k is a multiple of 27. If it is a multiple of 27, then this term is equal to 27m, where m belongs to the natural number, and taking this minus 14k that side, so it will be 27m plus 14 raised to the power k. Now we have to show that pk plus 1 is true. So what will be pk plus 1 in place of k, right? K plus 1. So this term is multiple of 27. This we wanted to show. Now taking this term, we have the value of 41 raised to the power k. So writing this term as 41 raised to the power k into 41 minus 14 raised to the power k plus 1. Writing the value of 41 raised to the power k, that is using 1. So the value is 27m plus 14 raised to the power k into 41 minus 14 raised to the power k into 14. We are writing this as 14 raised to the power k into 14. Multiply 41 with both the terms. 41 into 27m plus 41 into 14 raised to the power k minus 14 raised to the power k into 14. Now in the next step, taking 14 raised to the power k common from these two terms, what will be left? 41 minus 14, which is nothing but 27. So from both of these terms we can take 27 common. This is what we wanted to show, that this term is multiple of 27, and here we have shown that it is a multiple or divisible by 27. In place of divisible, you should write multiple, right? Because in the question it is multiple. Clear this question? Now next is question number 24th. So in question number 24th, it is less than type. We have to prove that 2n plus 7 is less than n plus 3 whole square. So first of all, assume the statement as Pn. Now for n equal to 1, LHS is 9. RHS will be 3 plus 1 4 square, which is 16. So 9 is clearly less than 16. Therefore P1 is true. Now we will assume that Pk is true, that is 2k plus 7 is less than k plus 3 whole square. Let this be as 1. Now we have to show that k plus 1 is true. So the statement will be in place of n, just put k plus 1. This will be our statement, that is 2 whole bracket k plus 1 plus 7 is less than k plus 1 plus 3 whole square. And this will be what? K plus 4 whole square, right? Now LHS will take LHS 2k plus 2 plus 7. As we know, 2k plus 7 is less than k plus 3 whole square. So this term will be less than 2k plus 7 is less than k plus 3 whole square plus 2 as it is, because we have used 1. Now the same LHS is less than, open this square, k square plus 9 plus 6k plus 2, which is k square plus 6k plus 9 plus 2 is 11. See, what we want to show that LHS is less than the RHS, and RHS is k plus 4 whole square. So we want to make this term as k plus 4 whole square. So what we have to do, as k plus 4 whole square is k square plus 16, right? And here we have 11. So we will add 5, and then 8k will come in the next term of k plus 4 whole square. Here we have 6k. So we have add 2k. To make our RHS as this, we have added 5 plus 2k. Also we can add this. Why? Because LHS, if our LHS is less than this term, then we are adding some term in this term. So LHS will be less than this term, right? And this is our only k plus 4 whole square. So this we got that LHS is less than k plus 4 whole square, that is Pk plus 1 is also true. Now we will discuss summary of this chapter as we have completed the chapter. So in this chapter we have studied about principle of mathematical induction. So principle of mathematical induction is used to prove the certain statements in mathematics that are formulated in terms of n, where n belongs to some natural number. So to prove such statements or formulas in mathematics, we use this principle of mathematical induction, right? What are the steps in PMI? So first step is assume the formula or statement given in the question as Pn, then check if the statement is true for P1 or not. Then assume that Pk is true. After assuming that Pk is true, show that Pk plus 1 is also true, and while proving for Pk plus 1, use your assumption in step 3rd. If Pk plus 1 is true, then you have to write down the result that Pk plus 1 is true whenever Pk is true. Therefore, Pn is true for all n belongs to natural number by PMI. So this is the complete concept of principle of mathematical induction. I hope all of you understood the chapter. Thank you. Today's homework is prepare for the test of chapter 4th, principle of mathematical induction. Okay.